What if the boundaries of human ability were never truly fixed? What if the limits we've always believed were real, of memory, strength, perception, and understanding, are not walls, but doors? And what if once in a great while those doors crack open just wide enough to show us what's possible? It begins not with a myth, but with the real, verified, documented, studied in hospitals, labs, and universities around the world. Individuals who break every rule we think we know about the human mind and body. People who should not be able to do what they do, yet somehow do. Take the case of Alonzo Clemens, a man struck by lightning in a Denver parking lot. He should have died. Instead, he walked out of the hospital days later with a mind transformed. Where once he saw numbers as meaningless marks, he now saw them as vivid shapes, colors, and conversations. He could calculate faster than a computer. But the lightning didn't give him new knowledge. It unlocked something already inside him. That is perhaps the most disturbing and inspiring part. In another part of the world, Daniel Kish moves through a crowded city. He was born completely blind, yet he rides a bicycle through traffic, navigating as if he could see, not by magic, not by technology, but by teaching his brain to interpret sound like vision. His tongue clicks echo off the world around him, and his brain paints a three-dimensional map using sound. His visual cortex, supposedly dormant, is lit up, active. He doesn't just adapt, he redefines what perception means. And what of memory? Jill Price remembers every day of her life since childhood, not just the milestones, but the mundane. The breakfast cereal, the exact weather, the conversations she had, and the commercials that aired. Her brain records life with a precision that no science can explain. She doesn't study. She doesn't try. She simply remembers. Always. These are not isolated anomalies. There are patterns. There are others. A woman lifting a car to save her son. A man navigating by magnetic fields. A savant drawing entire cities from memory after one glance. A healer who calms cancer with a touch. A linguist with an IQ below average but mastery of over 20 languages. Each case by itself is remarkable. Together, they form a mosaic of something deeper, the suggestion that the human species is far more capable than it appears. In this series, we'll journey through 14 chapters of the unexplained, the extraordinary, and the quietly revolutionary. This is not science fiction. It is the hidden frontier of human potential, laid bare by those few individuals who, for reasons we don't yet understand, stepped beyond the threshold. Each chapter begins with a mystery, a person, a moment, a phenomenon. We will explore what happened, what science has to say, and, most importantly, what it means. Because the real story isn't about them. It's about us. It's about what we might be capable of. If our minds were just a little more open. If our bodies were just a little less afraid. If the right spark found us at the right time. What happens when human limits aren't limits at all? Let's find out. It started with a storm. On a quiet evening in September 2002, a lightning bolt ripped through the sky over Denver, Colorado, and struck a man named Alonzo Clemens. By all rights, that should have been the end of his story. Instead, it was the beginning of something astonishing. Before the strike, Clemens was unremarkable, a quiet man, working maintenance jobs. Math, to him, had always been a foreign language, a blur of symbols and confusion. He couldn't make sense of basic arithmetic. But when he woke up in the hospital 3 days after the lightning strike, something had changed. Not just his memories or his moods. His brain had rewired itself in ways no medical textbook could predict. Suddenly, he could perform complex mathematical calculations in his head. 7-digit multiplication problems became effortless. He could solve differential equations without ever having studied calculus. Prime numbers appeared to him as colors. Equations turned into spirals, lattices, structures he could spin and explore in his mind like architecture made of logic and light. Neurologists were baffled. Brain scans showed unfamiliar connections, bridges between regions of the mind that usually speak different languages. Somehow, the electrical trauma had awakened dormant circuits, linking Clemens' visual centers with numerical processing regions. He wasn't doing math the way we're taught to do it. He was seeing it, intuitively, instinctively, as if the answers were already there, waiting for him to listen. When mathematicians tested his accuracy, they found something even more confounding. His answers weren't just right, they were elegant. Clemens solved problems using techniques that had never been documented. In one case, a solution he offered to a complex algebraic equation turned out to be more efficient than standard methods taught in universities. Asked how he did it, Clemens gave no formulas or techniques. He said simply that he talked to the numbers. They told him who they were. He listened. This wasn't learning. This wasn't calculation. It was something else entirely, something that hints at a deeper intelligence the human brain may be capable of tapping into under the right, if extreme, conditions. His case sparked a quiet revolution in neuroscience. Researchers began exploring the phenomenon of acquired savant syndrome, where traumatic events like strokes, head injuries, or electrical shocks awaken rare talents. Clemens became the symbol of a new question. What lies hidden within a typical brain? We often think of genius as genetic or practiced, years of effort shaped by opportunity. But Clemens wasn't trained. He didn't study. The abilities emerged fully formed, as if they had always been there, just waiting for the lightning to find them. And he is not alone. His story invites a haunting question. If trauma can unlock genius, what does that say about our own untapped potential? What abilities might be dormant within us, sleeping behind neural doors we don't even know exist? We may never volunteer to be struck by lightning, but perhaps the lesson isn't in the bolt, it's in the brain, in its vast, unexplored complexity, in the suggestion that we are not fixed beings, but shifting systems with capabilities we've only begun to imagine. Alonzo Clemens didn't just survive a lightning strike. He became a mirror, reflecting back a possibility we rarely consider, that inside each of us lies a different version of ourselves, smarter, faster, more perceptive, just waiting to be switched on. And that possibility, once seen, can't be unseen. Imagine navigating the world without sight. Now imagine doing it with more precision than someone who can see. Daniel Kish was born blind. His eyes were removed in infancy due to retinal cancer. But from a young age, he began making soft clicking sounds with his tongue, just like bats or dolphins. Over time, those clicks became his way of seeing. This isn't a metaphor. Kish doesn't stumble or grope his way through life. He rides bikes, climbs mountains, navigates busy streets, all using a skill science didn't think humans could possess: echolocation. By clicking his tongue and listening to how sound waves bounce off objects, Kish creates a mental map of the space around him. He hears walls, corners, trees, people, even their movements and shapes. His brain converts sound into vision. And here's the remarkable part. Brain scans show that his visual cortex, the part of the brain that processes sight, is active when he echolocates. He's not just hearing more clearly. His brain has literally reassigned sight to sound. What we're witnessing in Daniel Kish is neuroplasticity at its most profound. The human brain, denied one sense, doesn't give up. It reorganizes. It adapts. And in Kish's case, it does so in a way that defies traditional neurology. Scientists tested him under rigorous conditions. He could detect small objects from several meters away. He could distinguish between different surfaces, wood, metal, glass, just by the sound of the echo. He could even identify emotional expressions on faces by how muscle movements subtly altered the acoustics. Perhaps even more extraordinary, Kish can teach others. Through his nonprofit, World Access for the Blind, he trains people, many of them blind from birth, to develop echolocation skills. And it works. Brain scans of his students show similar activation of visual areas. They too begin to see with sound. This suggests that the ability isn't unique to Kish. It's not a mutation or fluke. It's a latent capacity in all of us. Think about that. The ability to map the world acoustically, to perceive shape, distance, texture, and even emotion without using eyes. This isn't fantasy. It's happening right now in real lives. What does that mean for our understanding of human perception? It means the senses are not as rigidly defined as we thought, that hearing can become sight, that the boundaries between sensory input and cognitive experience are more fluid, more creative than textbooks suggest. Daniel Kish lives in a world most of us never consider, the acoustic geometry of existence. For him, a room isn't just a space, it's a soundscape. A city isn't noise, it's architecture in motion. And in navigating it, he shows us a different way of being human. His story opens another door in the corridor of human potential. A reminder that when one ability disappears, another may rise, not through compensation, but through transformation. In a world obsessed with what we lack, Kish reminds us to ask instead, what else might we already have? What if the senses we think are fixed are just tools waiting for new instructions? And what if the key to unlocking them is not in our genes, but in how we learn to listen? It began with a memory, not a cherished recollection or a nostalgic image, but every memory, every hour, every day, every moment. Jill Price remembers her life in a way that no one else does, not just the highlights or the milestones, but the mundane, the trivial, the forgettable. She can tell you what she wore on a Thursday in 1988, what the weather was, what she ate, what was playing on the radio. It's called Highly Superior Autobiographical Memory, HSAM. But even that label barely captures what Price experiences. Her memory isn't stored in boxes to be retrieved. It plays like film, continuous, unedited, total. When researchers first met her, they were skeptical, but then they tested her. Random dates, random questions. Each time her answers matched historical data, personal journals, even TV schedules. The precision was unnerving. Brain scans revealed something equally unusual. The areas responsible for memory, especially the hippocampus and temporal lobes, were structurally different, larger, more active. But what was most remarkable wasn't just the recall. It was the effortless nature of it. She didn't try to remember. She couldn't help it. Her brain, it seems, was recording everything, automatically, like a surveillance camera pointed inward. But this gift came at a cost. Price called it a curse. She couldn't turn it off. Every memory, even the painful ones, came back uninvited. Old arguments, losses, embarrassments, they haunted her with the same freshness as the day they happened. And still, her case opened a door to a staggering idea that the human brain may be capable of storing far more than we believe. That forgetfulness isn't a failure of storage, but a function of design. Others with HSAM show similar patterns. Perfect autobiographical recall, normal memory for facts. It's as if the brain has a specialized recording system for personal experience, separate from the usual systems of learning and knowledge. What if this system exists in all of us but remains dormant? What if forgetting is a choice our brains make to protect us, to keep us sane? And what if a few people, like Jill Price, were born or became exempt from that choice? Her story challenges at the very foundation of how we understand memory. We often think of it as fragile, fleeting. But in truth, it may be vast and permanent, only hidden by neural filters designed to spare us the burden of total recall. Jill Price lives with those filters off. Her life is a library in perfect order, a timeline without erasure. And in doing so, she raises a profound question for us all. If we could remember everything, would we want to? Or does the grace of being human lie not in what we recall, but in what we're allowed to forget? The sound of metal crumpling, the scream of a child, a car jack failing. On a cold January afternoon in 2012, Angela Cavallo watched in horror as a Chevrolet Impala slipped off its jack and collapsed onto her teenage son, pinning him beneath 2 tons of steel. Without thinking, she ran to the car and lifted it. Neighbors witnessed it. Emergency responders confirmed it. Physics says she shouldn't have been able to do it, but she did. And she's not alone. Across decades, in moments of crisis, ordinary people have done impossible things. Lifting vehicles, fighting off wild animals, moving weights that exceed the limits of normal human muscle and bone. These events, often dismissed as urban legends, are documented, verified, and deeply unsettling. Scientists call it hysterical strength. Dr. Vladimir Zatsiorsky, a biomechanics expert, studied the phenomenon. Under ordinary conditions, a person can access about 65% of their muscle's full potential. During hysterical strength episodes, that number jumps to 100%. The safety systems in the brain that normally limit exertion are switched off completely. It's not just adrenaline. While adrenaline floods the body in these moments, researchers have found something more at play. The body temporarily rewrites its own rules. Pain disappears. Tendons hold firm under loads that should rupture them. Electrical activity in muscles spikes to levels unseen in controlled settings. Afterward, there's often no injury, no damage, just confusion and awe. In one case, a 110-pound woman physically wrestled a polar bear attacking a group of children, and won. In another, a man lifted the rear of a Cadillac to free a trapped cyclist. In both, doctors later confirmed the force applied was beyond what the body should tolerate. So, how does this happen? One theory suggests that the brain acts as a governor, like a limiter in an engine. What? It prevents the body from accessing its full strength to protect muscles, bones, and organs from tearing themselves apart. But in moments of extreme danger, the brain lifts that restriction. Just for a moment. It's not magic. It's not mutation. It's biology unleashed. The implications are profound. If the body contains this hidden reserve of strength, what else does it hold back? Could we train ourselves to access more of it safely? Or is this capacity meant to remain buried, summoned only when life demands the unthinkable? What makes these stories even more fascinating is their precision. The strength comes exactly when needed, then vanishes, leaving behind no bruises, only questions. Angela Cavallo didn't plan to be strong. She didn't train for it. In a single, terrifying instant, her body became something else. And then, as quickly as it came, the ability left her. Her story, and others like it, challenge our understanding of human limits. They suggest that what we call strength may be less about muscle and more about access, and that perhaps the boundaries we accept are not physical at all, but permissions granted or withheld by the brain itself. What would we become if we could tap that power, not in fear, but in focus? She sat at a desk, a quiet woman in a sari, her eyes fixed on a chalkboard. Then the numbers began to pour from her. Shakuntala Devi, known as the human computer, could multiply 13-digit numbers in her head faster than any machine. In 1980, she calculated the product of 2 massive numbers in under 30 seconds, faster than a room of mathematicians using calculators. Her answer was perfect, but what stunned researchers wasn't just her speed, it was how she described her process. Devi didn't memorize algorithms or crunch step-by-step solutions. She saw the numbers, felt their patterns, spoke of them as if they were old friends telling her secrets. To her, math wasn't work. It was a language, a rhythm, a song. When neurologists studied her, they expected to find some structural anomaly. They didn't. Her brain looked typical on scans. No lesions, no injuries, no tumors. Instead, they saw activity in areas of the brain not traditionally linked to mathematics, suggesting that Devi's abilities came not from one overpowered skill, but from novel pathways and hidden neural collaborations. She wasn't doing math faster. She was doing it differently. Geometries would appear in her mind. Prime numbers had personalities. Complex calculations resolved themselves visually, almost spatially, as shapes and colors. She wasn't solving equations. She was witnessing their solutions arrive. Devi's talents emerged early. By age 6, she was outperforming trained mathematicians, but her true gift may have been the way she taught others. She believed anyone could learn to love math, if they saw it not as memorization, but as discovery. Her methods emphasized patterns, not formulas, curiosity, not fear. And when her students followed her lead, something happened. They improved, rapidly, joyfully. This was perhaps the most provocative part of her story, not that she was exceptional, but that she believed others could be too. Cognitive scientists began to wonder, what if math isn't hardwired into a few? What if it's something most of us could access if we approached it through different cognitive doors? What if our struggles with math aren't signs of deficiency, but symptoms of a culture that teaches it the wrong way? Devi's brain, with its unorthodox wiring, showed us what the human mind might be capable of under different conditions. Her calculations weren't mechanical. They were intuitive, emotional, even playful. In the Western world, we often think of genius as a product of effort or IQ. But Devi was a reminder that genius can also be a shift in perception, a tuning of the brain to frequencies most of us never notice. She lived without fear of numbers. She danced with them. And through her, we glimpsed what numerical understanding could be, not a chore, but a kind of poetry. What if the real limitation isn't in our ability to calculate, but in the way we've come to believe we can't? Imagine always knowing where you are, even in total darkness, blindfolded, spun around in circles. Giuseppe Mercalli, a 19th-century Italian geologist, possessed a navigational gift so precise that it defied explanation. From childhood, he could walk through dense fog, through unfamiliar terrain, and still orient himself toward true magnetic north. Without maps, without instruments, he called it a feeling. A pull like a thread gently tugging behind his sternum. It never led him astray. When scientists began studying Mercalli in the early 1900s, they assumed he had honed exceptional spatial memory. But tests disproved that. He could determine cardinal directions with pinpoint accuracy in locations he had never visited. Indoors, underground, in cities, in wilderness, all without error. Eventually, researchers began to suspect something more radical, that Mercalli was sensing Earth's magnetic field. This shouldn't be possible, at least not in humans. Birds, whales, bees, and turtles are known to possess magnetoreception, a biological compass. But in humans? The idea has long been dismissed, and yet Mercalli wasn't alone. Modern studies have since found that some individuals can detect subtle shifts in magnetic fields. In one experiment at the University of Tokyo, subjects inside a magnetic shield room showed changes in brain waves when Earth's field was subtly altered. They didn't consciously notice, but their brains did. Mercalli's case was different. He felt the field directly. And more than that, he responded to changes in it. Before the 1908 Messina earthquake, one of the most devastating in Italian history, Mercalli reportedly sensed what he called magnetic dissonance in the air. He warned colleagues that something was coming. Days later, the quake struck. Retrospective analysis of major earthquakes has shown that electromagnetic fluctuations often precede seismic activity. But Mercalli didn't have sensors. He had a body that responded to those tremors before the Earth itself moved. Could he have been a biological magnetometer? Was his inner ear, or perhaps some unknown cluster of magnetite particles in his body, picking up signals we've learned to ignore? Modern imaging suggests humans might possess tiny amounts of magnetite, magnetic material, in the sinuses and inner ear. But we don't understand how it works, and most people never notice it. What Mercalli offers is a window into what might be a long-forgotten human sense, one that evolution gave us and culture helped us forget. A sixth sense, not supernatural, but sensory, biological, real. His story is less about predicting earthquakes or walking in the dark. It's about the quiet, strange possibility that we are tuned in to more of the world than we realize. We speak of intuition, of gut feelings, of knowing without knowing why. Perhaps those instincts are echoes of lost capacities, senses dormant but not dead. What if we didn't lose these abilities? What if we simply stopped listening? The helicopter hovered above the skyline. Below, a city unfolded, buildings, streets, bridges, rooftops vanishing in every direction. For most of us, it would be a blur, a sensory overload lost in motion. But for Stephen Wiltshire, it was a photograph. One glance and it was his. Diagnosed with autism at the age of 3, Wiltshire didn't speak until he was 9. But long before language arrived, he had already begun to draw skylines, cars, buildings, entire cities rendered in staggering detail. From memory. In one of his most famous feats, he took a 20-minute helicopter ride over London. Then, over the course of 3 days, he drew the entire cityscape on a 10-meter canvas. Every window, every arch, every rooftop, precisely placed. Perfectly proportioned. Urban planners use his drawings for reference. Architects marvel at his accuracy. And neuroscientists? They're still trying to understand how his brain does it. Scans reveal heightened activity in his visual cortex, the region responsible for processing sight. But what's more surprising is the bridge between that and his motor systems, the pathways that move his hand across the page. It's as if his eyes and his fingers speak in code, bypassing the slow machinery of conscious thought. His memory isn't photographic in the way people often misuse that term. It's architectural, spatial, alive. Wiltshire can capture not just structure, but atmosphere, reflections in windows, the angle of shadows, the subtle textures of rooftops blurred by smog. He doesn't memorize these things. He absorbs them, in silence. Then, without sketches or corrections, he lets them flow back out. Entire cities, reborn from within. When tested, Wiltshire could draw scenes with dynamic movement, traffic patterns, people crossing intersections, even the positions of cars at red lights. Time itself seemed to pause when he observed it, then rewind on paper. What makes his gift even more astonishing is its specificity. His talent doesn't generalize to all forms of memory or cognition. He doesn't excel in language or abstract reasoning. But when it comes to visual memory, he exists on a different scale. Some researchers believe his abilities may stem from enhanced synesthetic connections, a blending of senses that allows sound, light, and form to overlap. Others suggest that his brain filters out distraction more effectively, locking in only the most essential visual data. Whatever the cause, Wiltshire's mind reminds us of something profound, that the brain is capable of levels of precision and clarity far beyond what we normally experience. What he draws is not just a city. It is perception, distilled. His story is a quiet challenge to how we think about memory, not as a fragile thread, but as a vault, a mirror, a lens. And it raises a tantalizing question. If some among us can see and remember the world with such accuracy, What are the rest of us missing just by looking? He stood in the center of a room filled with silence and motion. The man known as João de Deus, or John of God, made no grand gestures. No machines hummed, no scalpels gleamed. Yet under his hands, people claimed to be healed, not by faith, not by ritual, but by something science could observe but not explain. In controlled settings, under the eyes of medical professionals, João performed procedures with nothing but his bare hands. People suffering from chronic illness, untreatable conditions, and even terminal diagnoses reported sudden recoveries. What began as hearsay quickly turned into clinical interest. Researchers from institutions like Harvard and the Institute of Noetic Sciences documented measurable changes. Tumors shrinking, blood markers normalizing, organ function improving, all without traditional medical intervention. Doctors examined João's diagnostic technique. He placed his hands on a person and described their internal conditions with uncanny accuracy. Without scans or tests, he identified tumors, infections, circulatory issues, and was right more often than not. What was happening? Brain scans of João during healing sessions showed unusual gamma wave activity. The patterns didn't match typical states of concentration, meditation, or empathy. They resembled something closer to deep flow cognition, a state of consciousness linked to heightened coherence between body and mind. But the changes weren't just in him. Patients undergoing treatment showed synchronized shifts in biological rhythms, heart rate variability, immune response, even cell regeneration speeds. Something in his presence, in his focused intention, appeared to catalyze healing. Skeptics, of course, pushed back. Was it placebo? Was it psychology? Was it fraud? And yet, independent labs measured real, repeatable results. Not all patients recovered, but enough did, in ways that shouldn't have happened, to raise difficult questions. Even more provocative, João claimed his abilities could be taught, and in some cases they were. Students who trained under him developed heightened sensitivity to biological signals. Some even produced verifiable healing outcomes. None matched his level of effect, but the pattern held. This led scientists to a controversial hypothesis that human consciousness might directly influence biological processes, not metaphorically, but physically. That healing isn't something the body does in isolation, but in response to attention, presence, and perhaps intentional energy. We are taught that mind and body are separate, that thought is vapor and matter is real. But João's work blurred that line. The boundary between belief and biology became porous. His story isn't easy. It resists explanation. It invites discomfort. But it also shines light on a frontier of medicine that remains largely unexplored. What if healing isn't always about chemicals and surgery? What if some part of us, some ancient hidden circuitry, knows how to activate the body's own recovery systems? And what if, through focus, connection, or something even simpler, we could learn to turn those systems back on? Christopher cannot tie his shoes. He struggles to tell time. He cannot handle money or navigate a city alone. His IQ, measured at 67, places him in the range of a severe learning disability. And yet Christopher speaks over 20 languages, fluently: Danish, Russian, Welsh, Hindi, Turkish, Finnish, Greek. The list goes on. Ask him to translate between any of them, even languages he's barely encountered, and he'll do it with precision. Give him a new language, created from scratch for study purposes, and within weeks he masters it. Syntax, vocabulary, even idiomatic expressions. Christopher's abilities defy every model of language acquisition. He processes and internalizes grammar faster than trained linguists. He recognizes complex patterns across unrelated language families, and he can explain what he's doing, despite not being able to manage simple life tasks. When neuroscientists studied his brain, they found enlarged and hyperactive language centers, especially in regions linked to syntax and phonology. But what made his case remarkable wasn't just the scale of his abilities, it was their specificity. His linguistic talent seemed to function independently of general intelligence. He couldn't multiply double-digit numbers, but he could conjugate obscure verbs in Estonian. This suggests something radical, that language may not depend on overall cognitive ability, that our capacity for grammar and expression could be modular, an internal engine operating on its own rules. Christopher's case supports the theory of universal grammar proposed by Noam Chomsky, the idea that humans are born with an innate framework for understanding language. But where most people need time, exposure, and repetition to activate it, Christopher's framework seems permanently switched on. What's even more astonishing is his metalinguistic insight. He doesn't just use languages. He can analyze and discuss them, identifying patterns and structures that even trained scholars miss. And he does so with joy, without effort. His abilities extend to sign languages, too. He picks them up as quickly as spoken ones. For Christopher, language isn't auditory. It's structural, symbolic, pure. And again, he is not entirely unique. Other savants show similar asymmetries, extraordinary talents coexisting with cognitive limitations. But Christopher's gift is a mirror held up to the rest of us. What if the human brain contains not one intelligence, but many? What if our skills are not general, but specific modules, some of which lie dormant unless activated by need, trauma, or rare wiring? His life is a reminder that talent may not always come wrapped in a package we recognize, that brilliance can live in unexpected places, and that the deepest parts of ourselves, those capable of beauty, expression, and connection, might not depend on intellect at all, just the right spark, and the right words, snow, ice, wind that cuts like glass. Most people would last minutes. Wim Hof, shirtless, barefoot, climbs toward the summit of Mount Everest. The temperature is below freezing, the air thin. His body remains calm, his core temperature stable. They call him the Iceman. Hof has become a modern enigma, not just for surviving extreme cold, but for thriving in it. He's run marathons above the Arctic Circle, submerged himself in ice water for nearly 2 hours, and scaled mountains in nothing but shorts. What's more astonishing, he's trained others to do it too. Medical researchers couldn't believe the claims, so they studied him. In laboratories, in controlled experiments. What they found shattered assumptions about the body's limits. Hof can consciously control his autonomic nervous system. His breathing techniques and meditation allow him to raise his body temperature at will, resist inflammation, suppress immune overreactions, and influence heart rate and blood chemistry. These are functions science long considered automatic, beyond voluntary control. Yet, under observation, Hof's results were clear. His immune system didn't respond like others. When injected with bacterial endotoxins that would make most people sick, he showed almost no symptoms. He controlled the response with breath alone. His brain scans revealed activation in areas linked to pain regulation and thermoregulation, regions previously thought inaccessible to conscious influence. He was overriding the hypothalamus, and doing it on command. But Hof insists he is not special. He believes this ability lives in all of us, and he's proving it. Thousands of students have trained under his method, showing significant increases in cold resistance, immunity, and even emotional resilience. Scientific follow-ups confirm these gains aren't anecdotal, they're measurable. What he teaches isn't mystical, it's physical, a mix of controlled breathing, focused attention, and gradual cold exposure. But the result is radical, conscious influence over the body's deepest automatic systems. It raises the question, what else might we control that we've long assumed we can't? For centuries, the divide between mind and body has been drawn thick and dark. Hof's work blurs that line. It shows that the barrier may not be real, or at least not permanent. What if the body listens more closely to the mind than we've been taught to believe? Wim Hof walks barefoot through the impossible and leaves footprints in the snow for others to follow. And in doing so, he reminds us that endurance is not just about strength, it's about awareness, breath, intention, and the rediscovery of a power we were never meant to forget. The boy was quiet, even withdrawn. His teachers didn't expect much. Then, one afternoon, he solved a complex geometry puzzle that had stumped the entire class, not by calculation, by seeing it. The boy's name was Alonzo, and he wasn't alone. Across the world, in scattered and sometimes tragic circumstances, stories have surfaced of individuals who awaken extraordinary mental abilities after trauma. Lightning strikes, head injuries, high fevers. These are not myths. They are cases studied by neuroscientists, logged in peer-reviewed journals, and verified by institutions. They point to a strange, almost unsettling possibility, that genius may lie dormant in all of us, waiting for the right spark or shock to activate it. In some cases, a child with autism begins drawing perfect architectural perspectives from memory. In others, a stroke survivor wakes up speaking a new language. A construction worker, after a head injury, begins composing music he never studied. What connects these phenomena is their sudden onset. These are not skills developed over time, but capabilities that seem to emerge whole without training or intent, fully formed as if unearthed. Neurologists now study these cases under the term acquired savant syndrome. Unlike congenital savants, people born with unusual abilities, these individuals gain their gifts through dramatic neurological events. Brain scans often reveal new or intensified connections between regions not usually linked. Visual centers crosswire with memory hubs. Motor control areas light up in tandem with mathematical reasoning. It's as if the brain, forced to reroute around damage, stumbles upon a hidden pathway and discovers a treasure buried within. But the abilities don't always come cleanly. They can arrive alongside compulsions, sensitivities, or emotional volatility. The mind that gains also struggles to adapt. Still, the implications are extraordinary. These cases suggest that the human brain may contain capacities far beyond what we use, and that trauma, in some cases, can serve as an accidental key. It leads to an uneasy thought. What are we leaving on the table? If our brains hold vast reserves of potential, why do we access so little? Are these capabilities too energy-intensive to sustain? Are they suppressed to protect us from overload or fear? Or have we simply lost the mental habits that once allowed access? In many indigenous cultures, altered states of consciousness were considered tools, not illnesses. Rituals, pitting, chanting, and movement were ways to shift perception, to rewire the brain without injury. Perhaps these savant cases are reminders, not of fragility, but of latency, not of damage, but of depth. The extraordinary abilities that emerge in trauma, survivors challenge the idea that intelligence is fixed, or rare, or owned by the few. They suggest it may be all around us, within us, waiting. 10 stories, 10 people, 10 impossible abilities, each one documented, verified, studied by scientists, doctors, and researchers. A man struck by lightning who becomes a mathematical savant, a blind traveler who sees through sound, a woman who remembers every day of her life with perfect detail, a mother who lifts a car to save her child, a man who climbs Everest in shorts, a childlike linguist fluent in 20 tongues. These aren't miracles, they aren't myths. They are mysteries, ones that challenge what we think we know about the human brain, the body, and what lies in between. What unites them isn't just the astonishment of their abilities. It's what those abilities reveal, that the limits we accept may not be biological, but learned, that the average human experience may only scratch the surface of what's possible, and that beneath the routine of our lives, the extraordinary waits. These stories reveal patterns, dormant systems, hidden senses, autonomic controls that, under pressure, become voluntary, memories that don't fade, strength that appears on command, languages absorbed like breath. Scientists who've studied these individuals often say the same thing: we don't know how this is possible. But it is. The final chapter isn't about one person. It's about all of us. Because the real question isn't how they do what they do, it's why we don't. Why do our brains filter so much? Why do our bodies protect us from our own potential? Why is genius, in many cases, unlocked only by trauma or crisis? Perhaps we were built to be more than what we've become. Not superhuman, but fully human. Not gods, but complete. And perhaps, somewhere along the line, we traded potential for predictability, power for comfort. But these individuals remind us the exchange was never permanent. Through discipline, through challenge, or through moments beyond our control, we can sometimes glimpse the edges of what we're truly capable of. The human brain is not a fixed machine. It is a living system, adaptive, dynamic, and mysterious. And the body, too, holds secrets: strength, regulation, intuition, resilience. The path to rediscovering those secrets may not be easy, but it has been walked before, in silence, in survival, in solitude. Now it's our turn to wonder, if these 10 people are possible, what else might be? We began with a question: what if the limits of the human mind and body are not what they seem? Now, at the end of this journey, the answer is both clearer and more elusive than ever. Yes, these 10 cases show abilities that break the mold, but more than that, they suggest something deeper: that our understanding of human potential is woefully incomplete. We've seen memory that doesn't fade, perception that crosses sensory boundaries, strength summoned at the edge of catastrophe, logic that arrives as intuition, healing that begins with presence alone. Each story whispered a similar truth: the extraordinary is not separate from us. It is within us. The boundaries between mind and body, between learned and innate, between possible and impossible, they aren't as solid as we once believed. They are porous, mutable, alive, and perhaps that's the real message: that being human is not a fixed state, but a moving horizon. A potential we grow into or away from, depending on how we live, how we challenge ourselves, and how we choose to see the world. These stories are not evidence of superhumans. They are reminders of untapped selves. The lightning strike, the sudden trauma, the focused breath, the overlooked gift, all point toward a central mystery. The brain and body are more capable than we've dared to imagine. But unlocking these capacities may not require crisis. It may require curiosity, discipline, stillness, or simply belief. Perhaps the future of human evolution isn't about enhancing our biology with machines or altering our DNA. Perhaps it's about learning how to access what's already there, waiting, quiet, unclaimed. And that leaves us with one final question. Not for the scientists or the savants, but for you. What have you always assumed was beyond your reach? And what if it isn't?